Our planet is, really a tapestry of diverse environments. Some teem with lush, vibrant life, while others present challenges that push existence to its very limits. Today, we journey to one such place. It is a realm of stark beauty and astonishing severity. We travel to southeastern Iran, to a vast expanse known as the Lut Desert. This desert is not just any arid land, it holds a remarkable and somewhat formidable distinction. The Lut Desert is famed as one of the hottest places on Earth. Its name, Dasht-e Lut, translates to emptiness plain, which is honestly a fitting title for such a landscape. The Lut Desert commands attention for its sheer scale and its extreme conditions. It stretches over an immense area, covering approximately 51,800 square kilometers. This makes it a significant feature on the Iranian plateau. Its importance, however, extends beyond its geographical size. The Lut Desert serves as a natural laboratory. Here, scientists can study geological processes. They can observe how life adapts, or fails to adapt, to intense heat and dryness. It is a place that tests the boundaries of endurance. Understanding the Lut helps us comprehend the incredible resilience of nature and the powerful forces that shape our world. This desert is a place of superlatives. It is not only incredibly hot, but also remarkably dry. Its surface features are sculpted by relentless winds into fantastical shapes. These formations, known as kaluts or yardangs, stand like ancient monuments. They are silent witnesses to millennia of geological drama. The Lut's reputation as a thermal hotspot is well documented. Satellite measurements have consistently recorded surface temperatures here that are higher than anywhere else on the globe. This makes it a crucial point of interest for climatologists and geographers alike, seeking to understand Earth's extreme climates. Our exploration will delve into the heart of this fiery wilderness. We will uncover the secrets of its formation. We will examine the climatic conditions that create such intense heat. We will look at the astonishing temperature records it has set. And we will ask a fundamental question: can anything survive in this seemingly inhospitable domain? Join me as we venture into the Lut Desert. It is a journey into a world where the sun reigns supreme, and the earth reveals some of its most dramatic and mysterious characteristics. A world that continues to fascinate and challenge us. The story of the Lut Desert begins deep in geological time. Its creation is, honestly, a tale of immense forces. These forces have shaped not just this desert, but entire continents. The Lut is situated on the Iranian plateau. This plateau itself is a product of colossal tectonic movements. Imagine vast plates of the Earth's crust. These plates have been colliding for millions of years. The Arabian plate is slowly pushing northwards. It crashes into the Eurasian plate. This monumental collision has buckled and uplifted the land, forming mountain ranges and high plateaus like the one where Lut resides. This region was not always a desert. Long ago, ancient seas covered parts of what is now Iran. Over millions of years, these seas retreated. They left behind thick layers of sediment. These sediments included salts and other minerals. As the land was uplifted by tectonic forces, a large depression or basin began to form. This basin became the cradle of the Lut Desert. It is a vast, enclosed area, surrounded by mountains on several sides. These mountains play a crucial role in the desert's character, as we shall see. The very foundation of Lut is thus tied to the restless earth. The type of rock and sediment found in the Lut tells this ancient story. Layers of sandstone, shale, and conglomerates speak of different environments in the past. There are also significant salt deposits. These are remnants of those long-vanished seas and ancient lakes that evaporated under an increasingly arid sky. The basin structure is key. It means that any water or sediment that enters the Lut has no easy way out. Over eons, this has led to an accumulation of fine materials, sculpted by wind and very occasionally by water, into the landscape we see today. Understanding this deep geological history is vital. It helps us appreciate why the Lut Desert is where it is. It also explains some of its unique features. The tectonic activity continues, albeit slowly. Earthquakes are not uncommon in Iran, a reminder of the powerful forces still at work beneath the surface. The Lut Desert, therefore, is not a static, unchanging place. It is a dynamic landscape, born from ancient upheavals and still subtly responding to the Earth's deep rhythms. Its story is written in its rocks and its very structure, a testament to geological time. While tectonic forces created the Lut Basin, another powerful artist has shaped its surface. This artist is the relentless wind. For thousands of years, winds have swept across this arid expanse. They carry sand and dust particles. These particles act like natural sandpaper. They abrade and sculpt the desert floor. The result is one of the Lut's most iconic features, the yardangs. Locally known as calottes, these are streamlined ridges carved from bedrock and consolidated desert deposits. They are aligned parallel to the prevailing wind direction, a clear indicator of nature's persistent hand. These yardangs can be enormous structures. Some rise to heights of over 150 meters. They stretch for many kilometers, creating a surreal, almost alien landscape. Imagine a fleet of giant, petrified ships sailing across a sea of sand. That is the impression these calottes can give. The winds, typically blowing from north-northwest during the hot summer months, are incredibly effective. They remove finer particles, leaving behind coarser material and carving these dramatic features. The scale of this wind erosion is truly staggering. It demonstrates the power of persistent directional force over geological timescales. The Lut Desert is not a uniform expanse of sand dunes, as some might imagine. While there are areas of sand seas, particularly in the east, much of its central and western parts are characterized by these yardangs. Other features include vast gravel plains and salt flats. The variety of landforms within the Lut is remarkable. Each tells the story of different erosional and depositional processes. The salt flats, for example, are formed in areas where occasional rainwater, carrying dissolved salts, collects and then evaporates. This leaves behind a crust of white, glistening salt crystals. The process of yardang formation is a slow, patient one. It requires specific conditions, strong, unidirectional winds, and suitable materials that can be eroded. The Lut Desert provides these conditions perfectly. The arid climate means there is little vegetation to bind the soil and protect it from the wind. The fine-grained sediments left by ancient lakes and seas are particularly susceptible to this aeolian or wind-driven erosion. Thus, the wind, working tirelessly day after day, century after century, has become the master sculptor of the Lut Desert, creating a landscape of breathtaking and unique grandeur. The extreme heat of the Lut Desert is not an accident. It is the result of a specific combination of climatic factors. One of the most important is its geographical location. The Lut lies within a belt of deserts that stretches across North Africa, the Middle East, and Central Asia. This region is characterized by large-scale atmospheric circulation patterns. These patterns create zones of sinking air. Sinking air compresses and warms. This process inhibits cloud formation and leads to very little rainfall, creating arid conditions. Furthermore, the Lut Desert is situated in a rain shadow. Mountain ranges, such as the Zagros Mountains to the west and others to the north and east, surround the basin. When moist air from the Mediterranean or the Indian Ocean attempts to reach the Lut, it is forced to rise over these mountains. As the air rises, it cools and releases its moisture as rain or snow on the windward slopes. By the time the air descends into the Lut Basin on the leeward side, it is significantly drier. This rain shadow effect drastically reduces the amount of precipitation the desert receives. The aridity is extreme. Annual rainfall in many parts of the Lut is negligible, often less than 30 millimeters per year. In some years, there might be no rain at all. This lack of moisture has profound consequences. Without water, vegetation is scarce. Without vegetation cover, the sun's energy directly heats the ground surface. Dark-colored soils and rocks in parts of the Lut absorb a high percentage of this solar radiation. This absorption further contributes to the incredibly high surface temperatures that the desert is famous for. The combination of these factors creates a powerful feedback loop. This loop maintains and intensifies the desert's aridity and heat. The Lut is essentially a natural basin that traps heat. The surrounding mountains also limit air circulation, allowing the air within the basin to become exceptionally hot during the long summer months. It is a climate forged in fire, a direct consequence of Earth's complex atmospheric and geographic systems working in concert. When we speak of the Lut Desert's heat, We're referring to some of the most extreme temperatures ever recorded on our planet's surface. But, honestly, measuring these temperatures isn't as simple as just placing a standard thermometer in the sand. Ground-based weather stations are really scarce in such remote and inhospitable environments, and well, the extreme conditions make maintaining such equipment very difficult. So much of our knowledge about the Lut's record temperatures actually comes from a different, more modern source: satellites orbiting high above the Earth. NASA's Earth Observing System satellites, especially Aqua, carry instruments like the Moderate Resolution Imaging Spectroradiometer, or MODIS for short. This instrument can measure land surface temperature from space by detecting the thermal infrared radiation emitted by the Earth's surface. Darker, drier surfaces, like those found in parts of the Lut, tend to absorb more solar energy, and, as a result, they emit more thermal radiation, appearing hotter to the satellite's sensors. These satellite measurements give us a comprehensive view of surface temperatures across vast areas, including places where humans rarely, if ever, venture. Now, it's crucial to distinguish between air temperature and land surface temperature. The record temperatures from the Lut are typically land surface temperatures, which can be significantly hotter than the air temperature measured just a few feet above the ground. Imagine, for a moment, walking barefoot on dark asphalt on a sunny day. The surface is much hotter than the air. In the Lut, the dark, barren ground can absorb so much solar radiation that its surface literally bakes. That's what the satellites are detecting, giving us valuable insight into these extreme thermal conditions. The data collected by MODIS over many years has consistently shown the Lut Desert to be a global hotspot. Specifically, a large area of dark lava pebbles and volcanic soil in the northern central part of the Lut, known as Gandum Berrian, is often the hottest. This region has repeatedly registered the highest land surface temperatures on Earth. The ability to monitor these conditions remotely has truly revolutionized our understanding of extreme environments. It allows scientists to track changes and pinpoint the most intense thermal zones without having to endure the dangerous conditions on the ground themselves. The Lut Desert's claim to being Earth's hottest spot is backed by compelling satellite data. For several years in the early 21st century, it consistently held this title. In 2005, NASA satellites recorded an astonishing land surface temperature of 70.7 degrees Celsius. That is 159.3 degrees Fahrenheit. This reading actually surpassed previous records held by other famously hot locations, like Death Valley in California. It was a clear indication of the extreme thermal environment that exists within the Lut's desolate expanse, particularly in its darkest, most barren regions. And this was not an isolated event. Data analyzed over multiple years confirmed the Lut's thermal supremacy. Between 2003 and 2009, satellite measurements indicated that the Lut Desert had the highest surface temperature on Earth for 5 of those 7 years. The consistency of these findings really underscores the unique combination of factors contributing to its extreme heat. The dark volcanic soil, the intense solar radiation due to clear skies, and the lack of moisture all play their part in creating this natural furnace. The specific area often recording the highest temperatures is the aforementioned Gandum Berrian Plateau. The very name Gandum Berrian, meaning toasted wheat in Persian, hints at the intense heat. Local legends tell of a caravan that left wheat in this area only to find it scorched by the sun days later. While perhaps apocryphal, the name reflects the local understanding of this region's extreme temperatures long before satellites could confirm them. The record of 70.7 degrees Celsius, or 159.3 degrees Fahrenheit, remains one of the highest, if not the highest, reliably measured land surface temperatures on our planet. Such a temperature is difficult to comprehend. It is far hotter than boiling water needs to be to cook an egg. It is important to note that these are surface temperatures. The air temperature a meter or two above the ground would be lower, though still exceptionally hot. However, it is the surface temperature that directly impacts any life attempting to exist there and drives many of the geological and atmospheric processes unique to such extreme environments. The Lut Desert, through these documented records, has firmly established itself as a benchmark for terrestrial heat, a place where the sun's energy is captured and amplified to an extraordinary degree, year after searing year. Given the Lut Desert's extreme temperatures and profound aridity, one might assume it is entirely devoid of life. Indeed, large areas, particularly the hottest central zones like Gandamberian, appear utterly barren. Satellite imagery shows vast expanses where no vegetation can be detected. The combination of scorching heat, lack of water, and often saline soils makes survival for most plants impossible. The conditions are simply too harsh, too unforgiving for the delicate processes of growth and reproduction that sustain plant life in more temperate climes. However, nature is remarkably resilient. Even in the Lut Desert, life finds a way, albeit in very specialized forms and in specific niches. On the fringes of the desert, or in areas where a little more moisture might collect, some hardy plants manage to eke out an existence. These are true extremophiles, plants adapted to survive where others would perish. They often possess remarkable adaptations. These can include deep root systems to tap into scarce underground water, small leaves to reduce water loss, or succulent tissues to store precious moisture. Common desert shrubs like tamarisk or saxaul might be found in these more peripheral or slightly more hospitable zones. These plants are masters of water conservation. Some may have mechanisms to tolerate high salt concentrations in the soil, a common challenge in desert environments where evaporation leaves salts behind. Their presence, however sparse, is a testament to the persistence of life. They form the base of a very fragile food web, providing sustenance and shelter for any animals that might also brave this harsh world. Yet it must be emphasized that the core regions of the Lut, especially the hottest parts, are largely sterile from a botanical perspective. The intense heat can literally cook plant tissues, and the lack of available water makes photosynthesis, the very basis of plant life, an insurmountable challenge. So, while life clings on in certain pockets, the overwhelming impression of the Lut's heart is one of an environment where the physical forces of heat and dryness have triumphed over the tenacity of the plant kingdom, creating a truly empty quarter. If plant life is scarce in the Lut Desert, what then of animal life? As with flora, the extreme conditions severely limit the diversity and abundance of fauna. However, just as some plants have adapted, so too have a few specialized creatures. These animals are typically small, nocturnal, and possess incredible adaptations to conserve water and cope with the intense heat. They are the true masters of survival in this unforgiving landscape, often unseen, operating under the cloak of darkness when temperatures are more bearable. Insects and other arthropods are among the most common inhabitants. Various species of beetles, ants, and spiders have been found in the Lut. Many of these are detritivores, feeding on any sparse organic matter they can find. Some, like certain tenebrionid beetles, have adaptations to collect moisture from dew or fog, should it ever occur. Reptiles, being cold-blooded, are better suited to hot environments than mammals or birds, but even they must be cautious. Lizards and snakes may be present, but they will spend the hottest parts of the day underground in burrows or hidden in crevices. Larger animals are exceptionally rare, especially in the central, most extreme parts of the Lut. On the desert's peripheries, one might encounter desert foxes, Ruppel's foxes, or various rodent species like gerbils and jerboas. These mammals are almost exclusively nocturnal. They have highly efficient kidneys to produce concentrated urine, minimizing water loss. Their large ears can help radiate excess body heat. Their survival depends on finding food, often seeds or insects, and avoiding the lethal daytime temperatures by remaining in cooler subterranean shelters. Human presence within the Lut Desert itself is virtually non-existent. There are no permanent settlements in its core. The conditions are simply too extreme for sustained human habitation. Nomadic groups may traverse its edges, and scientific expeditions venture in for short periods. But the heart of the Lut remains an empty, silent domain. The animals that do live here are a testament to evolution's power to shape life for the most challenging environments on Earth. They are whispers of existence in a vast, sun-scorched emptiness, each a marvel of adaptation. The Lut Desert, beyond its record-breaking heat and stark landscapes, holds an aura of mystery. Its vast, largely unexplored expanses continue to intrigue scientists and adventurers alike. The Gandum-Berrien Plateau, the toasted wheat area, is itself a source of fascination. While its dark volcanic rocks explain its high temperatures, the sheer intensity recorded there still sparks wonder. It remains a natural laboratory for studying extreme thermal dynamics and the limits of planetary surface heating. One of the enduring mysteries is the full extent of its biodiversity. While we know some plants and animals survive on its fringes, the deep interior remains largely unstudied biologically. Could there be undiscovered species of extremophile microorganisms, bacteria, or archaea thriving in the saline soils or within the rock formations, uniquely adapted to these incredible temperatures? The search for life in such extreme environments on Earth can also inform our search for life on other planets. Each expedition brings the potential for new discoveries. There are also whispers of archaeological significance around the periphery of the Lut. Ancient caravan routes once skirted this formidable desert. While the desert core was likely always impassable, its edges may have witnessed human activity for millennia. Discovering and interpreting any remnants could provide valuable insights into historical trade, migration, and adaptation strategies. The desert preserves what it claims, and sometimes it offers glimpses into the past. The Lut Desert, therefore, is more than just a hot, empty place. It is a dynamic geological entity, a climatic marvel, and a frontier for scientific discovery. Its stark beauty, its incredible power, and its lingering enigmas command our respect and curiosity. As we continue to study our planet, places like the Lut remind us of the Earth's incredible diversity and the profound forces that shape it. It stands as a silent, burning testament to nature's raw power, a landscape of extremes that continues to unveil its secrets slowly, one sun-baked grain of sand at a time.